Moving on to cathode ray oscilloscope, which is also called the CRO, is a very versatile electronic instrument which is in fact a high-speed graph plotting device. It works by deflecting beam of electrons as they pass through a uniform electric field between two sets of parallel plates as shown in the figure 14.3a. The deflected beam then falls on the fluorescent screen where it makes a visible spot. Here you can see the electron gun. CR is cathode ray oscilloscope. F is filament, C is cathode, G is grid, S is the fluorescent screen, A1, A2 and A3 are the anodes, 2 are the X plates, horizontal deflection plates, and 2 are vertical deflection Y plates. It can display graphs of function which rapidly vary with time. It is cathode ray oscilloscope because it traces the desired waveform with a beam of electrons, which are also called cathode rays. Beam of electrons is provided by electron gun, which consists of an indirectly heated cathode, a grid, and 3 anodes. The filament F heats the cathode C, which emits electrons. The anodes A1, A2 and A3, which are at high positive potential with respect to cathode, accelerate as well as focus the electron beam to a fixed spot on the screen S. The grid G is a negative potential with respect to cathode. It controls the number of electrons which are accelerated by anode, and thus it controls the brightness of the spot formed on the screen. Now we would explain how the waveform of various voltages is formed in your CRO. The two set of deflecting plates shown in figure 14.3a, 13a are usually referred as X and Y deflection plates because the voltage applied between the X plate deflects the beam horizontally on the screen parallel to the X-axis. A voltage applied across the Y plates deflects the beam vertically on the screen along the Y-axis. The voltage that is applied across the X plates is usually provided by a circuit that is built in the CRO. It is known as a sweep or time-based generator. Its output waveform is sawtooth voltage of period t. The voltage increases linearly with time for a period t and then drops to zero. As this voltage is impressed across the X plates, the spot is deflected linearly with time along the X-axis for a time t. Then the spot returns to its starting point on the screen very quickly because the sawtooth voltage rapidly falls to initial value at the end of each period. We can see that the spot moving on the x-axis, if the time period t is very short, we see just a bright line on the screen. If a sinusoidal voltage is applied across the Y plates when simultaneously the time-based voltage is impressed across the X plates, the sinusoidal voltage, which itself gives rise to a vertical line, will now spread out and will appear as a sinusoidal trace on the screen. The pattern will appear stationary only if the time t is equal to or is some multiple of the time of one cycle of the voltage on Y plates. It is thus necessary to synchronize the frequency of time-based generator with the frequency of voltage at the Y plates, and this is only possible by adjusting the synchronization controls provided on the front panel of the CRO. Uses of CRO are: the CRO is used for displaying the waveform of a given voltage. Once the waveform is displayed, we can measure the voltage, its frequency and phase. For example, shown the waveform of alternating generator in figure 14.14a. As the y-axis is calibrated in volts and the x-axis in time, we can easily find the instantaneous value and peak value of the voltage. The time period can also be determined by using the time calibration of x-axis. Information about the phase difference between two voltages can be obtained by simultaneously displaying their waveforms. For example, the waveforms of two voltages are shown in figure 14.14b. These waveforms show that when the voltage of one is increasing, that of two is decreasing, and vice versa. Thus, the phase difference between these voltages is 180 degrees.